The rectangular coordinate system is used in determining the slope of a line and in graphing linear equations in two variables. But what are linear equations in two variables? A linear equation in two variables is an equation that can be written in the form ax plus by is equal to c. Take note that a, b, and c must be real numbers. A is always positive, and b should never be zero. It is known as a linear equation since the exponents of both x and y are 1. And the two variables we are pertaining to are the variables x and y. Let us determine if the following examples are linear equations in two variables or not. Let's start with item number 1. 15x is equal to 10 plus y. Let us transform this equation in the form ax plus by is equal to c. How do we do that? Let us apply the addition property of equality, or the process called transposition. 15x will remain on the left side of the equation. Y will be transported to the left side of the equation. From positive, therefore, it will become a negative y. This is equal to 10. It is now in the form ax plus by is equal to c. A is 15. B is the numerical coefficient of negative y, and that is negative 1. C, on the other hand, is 10. A, B, and C are real numbers. A is positive and B is not 0. First qualification, check. Next, do we have two variables? Yes, we have two variables, and they are x and y. Third qualification, check. Next, are the exponents of both variables 1? The exponent of x is 1. The exponent of y is also 1. Third and final qualification, check. Therefore, the example in number 1 is a linear equation in two variables. Let's do the same in number 2. 3 times the quantity x minus y is equal to 15. In here, we first need to do distributive property of multiplication over addition. So we multiply 3 by x, that would be 3x. We also multiply 3 and negative y, and that is negative 3y. And this is equal to 15. Let's determine if we have two variables here. Yes, we do. The variables are x and y. Are the exponents of both variables 1? Yes. So, let's determine the values of a, b, and c. A is equal to 3. It's positive. B is equal to negative 3. It is not 0. And c, on the other hand, is 15. Since all of the qualifications for a linear equation in two variables were met, therefore, example number 2 is also a linear equation in two variables. What about the example in number 3? First, do we have two variables? We only have the variable n. Therefore, immediately we can tell that this is not a linear equation in two variables. And lastly, x squared minus 3y is equal to 84. Do we have two variables? Yes, the variables x and y. Are both variables linear? Let's find out. The exponent of y is 1, therefore that's linear. The exponent of x is 2. Therefore, it is not linear. In other words, the given equation is not a linear equation in two variables. One characteristic of linear equations is the slope of the line. The slope of a line is defined as the ratio of the rise to its corresponding run. It is denoted by the variable m. M from the first letter of the French word monter, which means to climb. The formulas for determining the slope of a line are rise over run, just like its definition, or the change in y over the change in x. The change in y means y sub 2 minus y sub 1, and the change in x means x sub 2 minus x sub 1. This could also be written as m is equal to y sub 1 minus y sub 2 all over x sub 1 minus x sub 2. But please take note that both x sub 1 and x sub 2 should not have But take note that x sub 1 should not be equal to x sub 2. Why? Because if x sub 1 is equal to x sub 2, the denominator becomes 0. And when the denominator is 0, division is not allowed. If in the numerator we started with sub 2, therefore in the denominator we should also start with sub 2. If in the denominator we have sub 1 first, therefore in the numerator we should start with sub 1. Furthermore, when we talk about slope, it means the gradient or the inclination of the line or how slanted a line is. There are 4 types of slants or slopes of a line. First of which is the positive slope, meaning to say the line rises to the right. On the other hand, negative slope means the line rises to the left. If we have a horizontal line, the slope of that line is 0. Whereas, if the line is vertical, its slope is undefined. Let us investigate further what positive, negative, 0, and undefined slopes mean. From point A to point B, let's determine the sign of the slope using the concept of rise over run. When we say rise, it means we move up. Since we moved up, that means the rise is positive. From here, we are going to move to the right. Since the direction of our movement is to the right, the sign is positive. Therefore, in the formula rise over run, the sign of rise is positive while the sign of run is positive. What again is a positive number divided by another positive number? The sign is positive. That is why this line here has a positive slope. On the other hand, negative slope here means the rise again is positive. We start with point A going to point B. So the rise is positive. And from this point, we move to the left so that we land at point B. Since we moved to the left, the run is therefore negative. In division, positive divided by negative results to a negative number. That is the reason why the slant or the slope of this line is negative. What about for a horizontal line? From point A to point B, the rise is 0. Why is that so? we did not move up. Next, the run is, if we go to the right, positive. If we move to the left, it's negative. 0 divided by any positive number or 0 divided by any negative number results to 0. That is why the slope of a horizontal line is 0. For a vertical line, let's move from point A to point B. The slope using the rise over the run is, we move up, therefore the rise is positive. However, we don't move to the right nor to the left. Therefore, the run is 0. Take note that any non-zero number divided by 0 is always undefined. Therefore, the slope of a vertical line is really undefined. Let us now determine the slope of a line given 2 points on the line. Let's start with the line passing through the points -2, 0 and 1, 2. Remember the slope formula. It is m, or slope, is equal to y sub 1 minus y sub 2 all over x sub 1 minus x sub 2. We have 2 points. The first point is located at -2, 0, meaning to say -2 is x sub 1, while 0 is y sub 1. The other point is located at 1, 2, meaning to say 1 is our x sub 2, while 2 is our y sub 2. Again, we have here point 2 and point 1. Let us substitute the points, or let us substitute the coordinates in our slope formula. We have m is equal to y sub 1, which is 0. The operation is subtraction, and y sub 2 is 2. That would be all over x sub 1, which is -2. Again, the operation is subtraction, and x sub 2, which is 1. Let us now simplify. The numerator is equal to 0 minus 2 is -2. In the numerator, we shall be having -2 minus 1 is equal to -3. Can we further simplify this? Yes. Negative divided by negative will give us a positive number. The slope, therefore, is equal to 2 over 3. But what if we make use of the other slope formula? Instead of y sub 1 minus y sub 2 all over x sub 1 minus x sub 2, let us have y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Let's do it here. The slope is equal to y sub 2, which is 2, minus y sub 1, which is 0, all over x sub 2, 1, minus x sub 1, which is -2. Let's further simplify that. The slope is equal to 2 minus 0 is 2. Negative, 1 minus -2 is 1 plus 2. Simplifying further, we shall be having 2 over 3. Using these two formulas, we arrived at the same value of the slope, which is 2 over 3. Meaning to say, both formulas are applicable. The slope of the line that passes through the points -2, 0 and 1, 2 is positive. Therefore, the line, when graphed, rises to the right. In determining the slope of a line, given the graph of the line, we are going to locate any 2 points on the line. It is more practical to make use of points that have integral coordinates. For example, this point here is located at 2, 1. Its coordinates are integral. The other point is the point which is located at 0, 4. Again, its coordinates are integers. Now, since we are given the graph of the line, we are going to make use of m is equal to rise over run. So, from point A, we are going to travel to point B using the concept of rise over run. However, we cannot do that diagonally. We have to travel vertically first and then horizontally. Let us count the number of units moved up and then to the right or to the left. From point A, how many units are we going to move up? 1, 2, 3. We'll stop there. Why? Because we are already aligned with the second point or the point B. So the rise here is 3. From this point, we're going to run to the left. Now let's count how many units are we going to move. 1, 2. Since we move to the left, that should be negative. How many units? 2 units to the left. Is that now the slope? Yes. The slope of this line is 3 over -2 or -3 over 2. Take note, the line is rising to the left. Therefore, its slope is negative. What if we don't like to use points A and B? Instead, we are going to make use of point C until point B. Will we be able to come up with the same slope? Let's find out. Point C until point B. We travel vertically and then horizontally. Let's count the number of units moved. 1, 2, 3, 4, 5, 6. Again, we'll stop there. We are already aligned with point B. The rise is 6. What about our run? The run is 1, 2, 3, 4, but it should be negative since we moved to the left. Can we further simplify 6 over -4? The answer is yes. Its simplified form is 3 over -2. We found out the same value for the slope. Why is that so? Because we are pertaining to the same line. Any 2 points on the same line will result to the same slope. We are done finding the slope of a line using any 2 points on the line and the graph of the line. This time, let's find out the slope of a line given its equation. A while back, we were told that a linear equation in 2 variables is an equation that can be written in the form ax plus by is equal to c. Linear equations in 2 variables could also be written in what we call the slope-intercept form of the line. It is in the form y is equal to mx plus b. Still, we have here two variables, the y and the x, whose exponents are both 1. Therefore, they are both linear. M here pertains to the slope of the line, while b is the y-intercept. So, if the equation of the line is written in the form y is equal to mx plus b, automatically, the numerical coefficient of the x term is the slope of the line. Number 1, y is equal to 30 plus 8x. That's already accepted. But let us rewrite that in the y is equal to mx plus b form. We shall be having y is equal to 8x and 30 will only interchange. We have 8x plus 30. Y equals m is 8, x plus b. In other words, the slope of the line here is equal to 8. And if we are going to draw the line, it should be a line that rises to the right since the slope is positive. Number 2, x plus 4y is equal to 8. In here, we need to apply the addition property of equality or the process called transposition. 4y will stay on the left side of the equation. X should be transposed from positive, it will become negative x, and 8 will be added to the right side of the equation. 4y should be divided by 4 because we only need 1y and not 4y. Since we divided the left side of the equation by 4, we also do the same to the right side of the equation. Negative x plus 8 all over 4. Let's simplify that. Y is equal to negative x over 4 plus 8 divided by 4 is equal to 2. This could be written as y is equal to negative 1/4 x plus 2. Again, the numerical coefficient of x in the slope-intercept form is the slope of the line. In other words, the slope of the line in number 2 is negative 1/4. If we are to draw the line whose equation is x plus 4y is equal to 8, it must be a line that rises to the left since the slope of the line is negative. Congratulations, students! Another set of treasures has been added to your learning box. See you again next time for a new set of lessons. These four regions, called quadrants, are named in a counterclockwise. Up next,
mx+b.com.
yung positive negative.
Calibration. Ay, well,
These numbers are in mali. Yung Roman numeral dapat yung hindi Indo-Arabic.
premiumbeat.com.
Are independent number lines. Therefore,
it's true.
Wala nang therefore.
Oo.
And since it is a pair of numbers, therefore,
Freemb.com.
ito. Shucks! It is a point which is located on the abscissas are wrong. Negative slope, on the other hand, means the line is on the other hand. That is why this slope here, that is why, what does the slope 2/3 mean? It means for every 2 units.
Freemb.com.
Wag na.
Or sabihin mo na lang positive. Let's look.
Freemb.com.
Let us count the number of units that we are going to let us count the number of units.
Move.
Should we be able to will we be able to what if this time wala, tama na yun.
Freemb.com.
We already found we already did finding the we are done. Number 2, x is equal to